Hey everyone and welcome. Today we're going to dive into a pretty wild new idea about how the universe actually works. It's a theory that says everything we see and know, from the tiniest little particle to the biggest galaxy, might just be different patterns on a single fundamental fabric, a fabric that is reality.
So try to forget the idea of particles being these little solid dots zipping around. The big question we're tackling today is, what if they're not that at all? What if particles are actually just stable, localized wrinkles, maybe some twists and distortions, in the very fabric of reality itself?
Okay, so here's how we're going to break this down. First, we'll look at this new view of reality. Then, we'll clear up the difference between Einstein's spacetime and this new spacetime. After that, we'll see how this whole idea completely redefines particles and even gravity. And finally, we'll talk about the hunt for new, undiscovered shapes that might be hiding in this fabric.
All right, first up, let's introduce this new view of reality and what we mean by a fundamental fabric of existence.
The core idea here is something called spacetime, and you really have to pay attention to how it's spelled, a capital S and a capital T. Now that's not just for show. It's super important to separate it from Einstein's concept. This spacetime is supposed to be the actual underlying fabric of everything, the source from which matter, energy, and even spacetime as we know it comes from.
So, let's really nail down the difference between Einstein's spacetime and this new idea of spacetime. Getting this distinction is pretty much key to the whole theory.
Okay, so on one side you've got Einstein's spacetime, all lowercase. You can think of that as the stage, or the arena, where all the events in the universe play out. But on the other side, you have this new concept, spacetime, with the capital letters. It isn't the stage, it is the show. It's the active, dynamic stuff that actually makes up reality itself.
You know, this brings up a classic challenge in physics. How do you actually connect the dots between what you see in an experiment, the data, the blips on a screen, and these really elegant, abstract mathematical theories that physicists write down? How do you make that leap?
Well, it's kind of a three-step dance. Step 1, you have the actual experiment in the real world. Step 2, you have the math, the theory, on paper. But the third step is the most important one, the connection. It's sometimes called analogy reasoning. This is where scientists build a bridge and show that the math from the theory perfectly predicts the patterns they're seeing in their experiment.
All right, now for what I think is the most mind-bending part of all this, the idea that particles are just distortions. This is where we really get into these so-called wrinkles in reality.
For about 100 years now, physics has been dominated by quantum mechanics. And because the math behind it is just so incredibly good at predicting things, most physicists came to believe that reality itself must be quantized, made of these tiny, indivisible little packets, like pixels on a screen. But this new theory offers a totally different take. What if the reason things look quantized isn't because reality is made of tiny bits, but because only certain shapes, certain distortions in the spacetime fabric are stable enough to stick around? These specific stable wrinkles locally relax the fabric, which lets them persist. And what do we see? We see those persistent wrinkles as particles. So here's the kicker. The particles we already know about, all the fermions and bosons and what's called the Standard Model, they aren't the only possible wrinkles. According to this theory, they're just a very special, specific type. They happen to be the most stable and the most symmetric distortions. You could almost think of them as the simplest, most perfect wrinkles possible.
And this really puts into perspective how much we might be missing. I mean, look at this. All the particles we've ever discovered might just be this tiny little slice of all the possible ways the spacetime fabric can be distorted. We could literally just be seeing the very tip of the iceberg. And that whole other hidden part? Well, some physicists are starting to wonder if that could be where we find answers to huge cosmic mysteries, like dark matter.
So this brings us to gravity. Because in this model, gravity isn't some mysterious fundamental force. It's actually just the sum of all the parts. So get this. In this framework, gravity isn't a fundamental force that pulls things together from a distance. Nope. Instead, it's what's called an emergent effect. It's the large-scale consequence of trillions upon trillions of those tiny little particle wrinkles all tugging and reshaping the fabric on a massive scale. This quote just connects everything back to Einstein so perfectly. Energy deforms spacetime, because energy is deforming spacetime. Just think about that for a second. Einstein told us the what, that energy and mass curve spacetime. This new theory tries to explain the how by saying that energy isn't just in the fabric, it is a deformation of the fabric. You can really see the evolution of the idea right here. Back in 1915, Einstein used pure logic and a thought experiment to deduce that spacetime had to be curved. This new theory is trying to go a step deeper. It's trying to derive that same curvature from something even more fundamental, the combined effect of all those tiny wrinkles. It's a shift from just describing an effect to trying to explain its physical cause.
So, where does all this leave us? Well, that brings us to our final section, the search for new shapes, and what could be waiting for us beyond the standard model of physics.
Really, the whole point of this new line of thinking is to get us to stop seeing particles as just points on a graph, and to start asking, what are they really? What is their true shape? What is their actual form? What's their internal structure as a distortion in the fabric of reality?
And that leaves us with one last, truly massive question to think about. If all the particles we know and love are just the simplest, most symmetric wrinkles out there, what other, more complicated, maybe even bizarre shapes are hiding in the fabric of spacetime, just waiting for us to find them? Thanks for joining me on this one.